Welcome students. In this short video, we will be discussing two conceptual problems on rotation. Conceptual problem 1. If the total external force acting on a rigid body is 0, then only linear momentum remains constant, only angular momentum remains constant, both linear momentum and angular momentum remains constant, neither linear momentum nor angular momentum remains constant. So here it is given that total external force on the rigid body is 0, but there is no information about the net torque on the body. Now we know from law of conservation of linear momentum, if the net external force is 0, linear momentum remains constant. So in this case, since the net external force is 0, linear momentum will remain constant. Now we also know that law of conservation of momentum says that if the net torque is 0, angular momentum will remain constant. Since in this case there is no information about net external torque about the rigid body, so we cannot say anything about the angular momentum of the rigid body. So only option A is correct in this case. Conceptual problem 2. A ball of mass capital M is tied to the string of length L, is whirled around in a horizontal plane in a circle of radius R. The speed of the stone is increased beyond the maximal permissible value and the string breaks suddenly. There are four options. The ball will jerk radially outwards. The ball will jerk radially inwards. The ball will fly off tangentially from the instant the string breaks. None of the above. Now, in this case, when the ball moves in the circle, the velocity of ball at each point in the circle is tangential to the point of the circle. When the string breaks, the force stops acting and the ball will move in a direction of velocity. That is, the ball will fly off tangentially from the instant the string breaks.